Arkadaşlar kaydı başlattım. Tekrar hoş geldiniz dersimize. Abbas hocam dersi anlatmaya devam edecek. Ben de burada sorularınız olursa yardımcı olmaya çalışacağım. Abbas hocamın müsaadesiyle. Teşekkür ederim. Kolay gelsin.
Evet arkadaşlar, Muharrem hocamın da belirttiği üzere Muharrem hocam da burada. Ben de dersi anlatmaya çalışacağım. Laboratuvar kısmını. Yardımcı olmaya çalışacağım daha doğrusu. Önemli olan nokta arkadaşlar şu. İşlediğim, anlattığım kısımla ilgili herhangi bir sorunuz olduğunda lütfen sesinizi açın. Hocam anlamadım, hocam şurası ne demek falan diye araya girin lütfen. Çünkü bunu indirdiğim zaman göremiyorum sizin ne yazdığınızı. Bildirim olarak da gelmiyor bana. Bunu dikkat edin arkadaşlar. Onun dışında bu haftaki konularımız loop, decrement ve increment keywordleri, instruction'ları. Yeterince arkadaşımız biriktiyse aslında kayda başladık. 8 kişiyiz. Tamam, artık bundan sonra gelenler de kayıttan devam ederler izlemeye. Tamam hocam. Okay, my friends. Today's topics is loops, actually. The other two instructions is the decrement and increments are both of them as very simple instruction. I will cover them at the beginning of this session easily. After that, we are going to create loops with assembly language. Loops are easy to create with labels. I'm going to explain this in detail. Don't worry about it. Description is here if you want to read it. Also, remember, when we come to a new instruction, as always, we should open help documentation and instruction set. At here, there are various loops, as you can see. These are all kind of loops in here. The difference is actually loop, simple loop, loop equal, loop not equal, loop not zero, loop zero. For example, when I go to loop, there's a condition explaining about loop. When I go to loop E, loop equal, there's another condition. Actually, these are the same things, but for example, loop E is looking for another flag in order to jump. I will explain it. So, for now, just know that loop is enough for us. And we will cover these loop keywords. Before going loop, I will mention decrement and increment. Azaltma ve arttırma. Decrement, increment. I'll go over the instruction set and open the decrement function. Decrement function, as we know, this is the instruction column, this is the parameter column, this is the explanation part. Instruction is decrement. Let's write directly in here. Instruction is decrement. Parameter is either register or memory. It can be register or it can be memory. Remember, when we say memory, address of something is memory, directly accessing those memory location. So this is decrement. Be careful. This is a single parameter instruction. You can't use decrement AX with 2. This is wrong usage. There is no second parameter for decrement. Also, increment. Increment is also same. One parameter instruction. It is also can be register and also it can be also memory too. They are same single parameter instructions. In C, just remember I++. You may already know this, increasing I by 1. So this is doing the same thing. And this is exactly the same of I minus minus, decrement AX, or AX minus minus BX plus plus. Okay, increment and decrement is this. Let me show an example directly using AX. I'm going to put 5 in AX, 5 hexadecimal, and decrement AX. This is value into 1000H in order to see some value change in there. Let's put 3 in there. Okay. Increment BX, increment 1000, and return. Let's emulate this code. Okay. We put 5 to AX. AX is 5. Remember, updated values will be brown, blue. So instruction pointer and AL is updated. Decrement AX. We are saying that AX minus minus. Decrement AX. So that AX become 4. Did you catch that? It's reduced by 1. Okay, now we put 3 in 1000H. When we go over and look at the physical address of 1000H, which is 2000, the value is 3. So decrement 1000H, the second instruction after that, it is already done, and go over and look at the 1000 address, which is 2000 physical address. It becomes 2. It decreased. Now increment BX. BX become 1, and increment 1000H. 1000H has become 3 again. Increment and decrement is this. Is there any question about increment and decrement? Let me see the text version. Any question about increment, decrement? It's very straightforward. It's just increment the register or memory, or decrement. So that's it. Let's make this a bit different. I'm going to put hexadecimal 16-bit value into AX, and I'm going to increment AL, or I'm going to decrement and AH and increment AL. What will be the result? Any idea? You can write your guesses if you want. I put 1122H into AX register, and I decrement a higher boundaries of AH, and increment lower boundaries of AL. Is there any guess what will be the result of AX? Result of AX may be 0. Let's emulate any idea. 1023. Yep, but H, 1023H. This is important. Okay, open the emulator. Move 1122 in the AH, AL, which is AX. Increment AH by 1. AH become 10H. And increment AL become 3. So AX become 1023H. Okay, is there any question about this? But for example, let me increment AX. What will be the result, really? After it become 1023, I increase the AX. What will be the result? Why 1124? We just increase AX by 1. Let's go and look at the emulator. 1122, AH is decreased by 1, AL is increased by 1, so it is 1023. Now I increase AX completely, 16-bit register. It becomes 1024. Yep, 1024. So be careful. It is important what you are working on. You are working on AH. It's different from AX. You are working on AL. This is completely working on AX. So it is important. Just be careful. Okay. Okay, we already covered that. Is there any question? I'm going over to loops. Okay, loops. Let's go over the instruction set and open loop. Instruction is loop. It only gets one parameter, a single parameter, which is label. Label means anything. Keyword and a label. Label can be anything. Can be label also, label 1, label anything. It can be anything, so I'm going to use Abbas in here. What is Abbas? Is a location of some instruction in the instruction list. For example, in here there are some codes going on, etc. Let's not put spaces between these lines. And here I want to create a loop. And this loop should contain subtract command. This is the label. You have to put semicolon at the end of a label so that this loop keyword know that where is this label. After these subtractions, I'm going to increase AX, and increase AX so that AX become the same value which is at the beginning. Okay? After that, return. I'm going to emulate this. When we emulate this, it puts 73 into AX. Now subtract 3 from it. It's 70. Increment AX, increment AX, increment AX. Now it comes to loop section. When it comes to loop section, I'm going to open the help section. Algorithm is this. It decrease CX, jump to label if CX not 0. Let's look at here. CX is 0. It decrease CX. CX become -1. Jump to label if it is not 0. It is not 0, so it's jump. When I run this code, it's something meaningless loop. But the meaningful loop should be something like this, putting some value into CX. For example, I'm going to create a 3 times running loop. This loop is going to be run 3 times. Why? Because loop, look at the CX. If it is not 0, it jumps. By the way, loop decreases CX itself. So this loop run only 3 times. First time, second time, third time, and end. I'm going to reload this session and I want you to look at the CX value. Okay. Let me run this code and look at this. Running. Sorry. Run this code and look at the CX. CX is 3, CX is 2, CX is 1, CX is 0, and loop is finished and program is finished. But you may have already understand that we didn't update the CX. Loop keyword automatically decrease CX. So let's write this code in C. I create CX variable and said that it is 3. I want to be this CX to be greater than 0, and I decrease CX by 1. This is the loop that you have created. It can be for loop, to while loop, it's up to you. Okay, for loop, initialize a variable and use that variable as a conditional statement and update those variables. This is what's going on in here. We initialize CX with 3 and we check if it is 0 or not. If it is 0, it exit. If it is not, it goes and decrease CX by 1. This is exactly the same thing in assembly. Within this loop, there is no parentheses, so these keywords are actually parentheses, curly brackets, etc. So this is loop. Be careful. You have to use keyword label, and after that label, you put semicolon. I want you to show something. This is the code we have written. This is the code that machine understands. For example, move AX73. This line is same. It just put zeros at the beginning of it. Okay. Move CX3. This line is same. After that, the third line is subtract AX3. But our third line is our label. So labels are emitted. We don't use labels in the machine language. And goes to next line. This is subtract. This is increment. Okay. Increment, increment. And loop. When we came at the loop, you may catch that there is no label, just a number. This number is the next instruction that needs to be done. Actually, this is the position of this command. The first instruction after this label. Let me show you that in instruction pointer. Remember, we don't update the instruction pointer. Instruction pointer update itself and shows the next instruction which will be run. Okay, instruction pointer saying that the 0th line will be run because we didn't run the program yet. We go over and it says the 3 will going to be run, which is 1003 move CX. Okay, next instruction 6. 6 will be run, which is subtract AX3. This is the 6th instruction. Instruction pointer showing that 6, which will be done. So when we came to loop, instruction pointer is C, but CX is not 0, so instruction pointer will be updated with the position of subtract command, which was 6. When we go to next, instruction pointer becomes 6. So labels works like this. They are just the memory locations of instructions. Okay. For example, I'm going to change the location and add some code in here. Move AX, CX, etc. Remember, previously Abbas was pointing the 6th instruction. Now, when we came at the loop, it's going to jump to what? 8. Why? Because there are other instructions beforehand. So that's why it's updated. Now it continues to 8 because subtract command, which is after Abbas label, is going to be run next. Okay? Any question? Can we define the label after loop statement? Okay, let me show you what will happen if you define the label after loop statement. Let's say label is here. I'm going to erase this parenthesis, blah blah. Close this one. What will happen at this code? I'm going to delete this one, so I'll simplify that. Emulate this. We put 73 into AX, 3 in CX. Now we came across the loop. What loop does? Loop decrease CX and jump to label if CX not 0. I'm going to go over and look at the CX value. CX is 3. It will decrease CX to 2. So CX is not 0. So it's going to jump to Abbas. And program finish. So this is not loop. This is just a dead code. For example, let's change this into 1, and this code will become run because loop decrease CX 1, CX becomes 0. When CX becomes 0, it didn't jump, and next code will be run. But this is also not a loop. So be careful. In loops, labels must be for loop keyword if you want to create a loop. Okay? Other question. Will it work the same way if we use a register other than CX? No, you can't use any register other than CX. Loop keyword only look at the CX. For example, I put 3 in AX. There are some instructions in here. When I emulate this, it will go like that. Look at the CX. CX is 0. CX is currently 0. Loop decrease this value to 1. When you decrease 0 by 1, it becomes -1. -1 is not equal to 0, so it jumps. But this is a meaningless loop because it's going till -128. As you can see in here, CX is decreasing. It just looks at the CX. CX gather its name from actually the counter. CX is counter register. So it counts to loop iteration. Okay, you have to use CX in order to control how many times this loop run. Loop statement. Last son kısmı özetleyecek misiniz? Son kısım. What was the last part? Mehmet. What was the last part? What do you mean by last part? Tamam, okay. Loop keyword çalıştıktan sonra CX'i biraz azaltıyor. Loop'a geldiğinde değil de çalıştıktan sonra. Mesela CX şu an 3 çalışıyor. 2 0 olmadı, atladı. Şeklinde. Var mı başka sorusu olan? CX önemli arkadaşlar. It only works with CX. You can't change this. It's predefined, hard-coded value. So what are some things I need to mention? Loops, semicolon, it's important. If you forget to put semicolon, it gives error. There is no semicolon when calling label. We call this label. We are telling program to go over to this instruction. So include, not change, not zero. Yeah. Let's go over and look at the examples. Let's write these examples if there isn't any question. I think there is no question for now. Let's look at the program example code question. Write a program that calculates the sum of the numbers from 1 to 100 and says result to do memory address 1000H. We are going to save result into 1000H address, 100 and 1000H address, but we need to find the summation of these all numbers. So we have numbers 1, 2, 3, 4, 5, 6, 7, goes like that, 97, 98, 99, and 100. We need to add all of these numbers. What we are going to do, we are going to create a loop. Within this loop, we are going to add all these numbers. Let's create a loop by using Appas again. This is loop. This loop needs to be run at some times, CX times. So what will be the number of CX? What we are going to put in CX? An idea? What we are going to put in CX? What will be the value of CX before this loop starts? 100, Mohammed says 100, Emre says 100. Okay, everyone is agree about 100. 100H or 100? Any idea? 100H or 100? Decimal, yeah. It should be 100 times run, but you can use 64H, which is 100, or 100 decimal. These are same things. It is not important if it is 101 or 99. I don't doubt that. So don't worry about these things. It can be 99, 101. It's all correct for me. The main idea is not that. At the end of we have that. Okay, now what? These loops is going to run 100 times. What am I going to do within these loops? I need to add numbers. I know I can use add operation. And let's say store these values into AX. And I'm going to put some value in it. For example, this loop. I run this loop. Let me see your text. We put 100, 64H in CX, and add one into AX. This loop goes like that. As you can see, CX is decreasing, AX is increasing, but it keeps adding 1. So this needs to be changed. This shouldn't be 1, but something other. For example, let's say we have 1 in BX. I'm going to put BX in AX. I'm going to increase BX by 1. Increase BX by 1. Correct? No, not. It's not correct. Increment operation can only take one parameter. So increment bx is enough. Okay. Emulate this code and see what it is doing. Add bx into ax. Ax is now 1. Increment bx, it's 2. Add 2 into 1, it's 3. Bx is 3. Add 3 into 3. Ax is 6. Goes like that. Ax accumulating, as you can see. Let's run this code and see until Cx is 0. Let's run this a bit fast. Okay, the result is 13BA. 13BA. Let's open programmatic 13BA, which is 5050. How do you calculate the total number between summation of these total numbers between 1 and 100? The last element plus first element divided by increase operation plus 1 something. There's a, yeah, the last element plus 1 or something. Okay, we calculate correctly as Emre says. So this is the correct code. We create a, we have used 3 variables, Cx, Bx, Ax. Let's reduce this usage. How to reduce this usage? An idea. How can we get rid of some variables? We are using loop. We can't get rid of the Cx, but let's try to get rid of these A and B. An idea. How can we get rid of these values? Okay, we are accumulating the result into Ax. Okay, we keep adding Bx into Ax, adding Bx into Ax. But I know that add function also work with memories, memory to registry. So I'm going to update this Ax with 1000H so that Bx keep inserting into 1000H address. Okay, so I get rid of the Ax. This is still correct. Let me run this code. Blah, blah, blah, blah, blah, blah, blah. Yep, let's go over and look at the 1000H. It is 13BA. 13BA is 16-bit value, so it's stored in 2000 and 2001. So it's a word, 16-bit. 13BA, the result is correct. So we get rid of the AX. Now get rid of the BX. Any idea how to get rid of BX? Come on. How to get rid of Bx? We create a new variable and we are increasing it. We are calculating the value starting from here. 1 plus 2 plus 3 plus 4 plus goes like that. But we can also start from here. 100 plus 99 plus 98 plus 97 plus using Cx. Exactly. Cx is already here. And Cx is already decreased by loop. So I'm going to use Cx. And I'm going to delete this line. And I'm going to delete also this line. Cx is 100. We are starting from here. 100. Loop is decreased to Cx. 99. Loop decrease Cx. 98. Let's run this code. By this time, faster than normal. Okay. Let's go over and look at the 1000H. It is 13BA. We find the same results by only using a single register, which is Cx, that we have to use in order to use loop. Okay, any question? No question, I think. Now go over to next question. Write a program that reads values from 1000H, 1200H memory range. There's a memory range. Between these values, read value from this range and write this range back to 1000 and 1200H, this memory range. But this time, segment is changed. It was in 100. Now it wants you to copy this value into 300 segment. And by copying, it wants also something. It wants you to add 1 to every word before writing back to memory. So actually it wants you to, let me show you the memory range for you. Here is the 1000, 100 and 1000 location, which is the physical address is 2000. It wants you to copy this range starting from 2000 to 2200. 2200 until here. Until here, between this range should be copied into 4000 range. So the physical address of 2000 range copies into 4000 range. But there's a range which is 2200 and 4010, 200 H. These are all H. By this copy operation, you have to put insert one, increase by one every word. It's important, every word. So I need a loop, as it is obvious. Again, I'm going to use Abbas as a keyword. Close this one. Loop keyword, Abbas. So loop keyword, looking at the CX value. What will be the CX value? Memory ranges from 1000 to 1200. It's actually 2000 to 2200. How many times should this loop run? Any idea? 200H, said Ahmed. It's correct. Any other idea? Ahmed, you were thinking right, but question explicitly stated that you have to use word by word, every word. Word is 16-bit. So when we emulate this code, every line is 8-bit. Every word is 2 line, 8-bit, 8-bit, 16-bit. So you have to calculate the range according to that, so that by 2 it becomes 100H. Okay? Because every 16-bit memory will be copied into this range, we are going to increase by 1 every word. It's important. So this loop will run 108 times or 256 times. Okay? What will be the value of, let me ask you a simple question. What will be the value of, what will be the result? 100h minus 1h. What will be the result? 100h minus 1h. What will be the result? Any idea? Hexadecimal subtraction operation. Exactly. It is FFH. It's not 99. Be careful. It's not 99. It's FF. 0FF, actually. That's the more correct way. Okay, be careful. This is 100H, 256, 255, FFH. These are all acceptable from me. Just be close to this. Okay, now we have loop. We are going to copy this move some value into, for example, registry. This value is at 1000H address, but we have data segment at the beginning of this here, and we get this value, increment by 1, and put this value into richest 300 segment to 1000H of what? AX. It wants something like that. This is abstract. This is not correct. There are errors, but I want you to understand the concept. We are copying value from memory to register, increase those register by 1, and write it back to 300 segment position. Okay. Now we need to do this by changing or using data segment or exa segment. In the question, it's also force us to do data segment source index and exa segment destination index twins. Remember those twins: exa segment destination index, data segment source index. I'm going to update data segment and also update exa segment. Exa segment is 300, data segment is 100. Is this correct? Is this the correct way of updating segments? When I emulate this code, it gives error. Did you remember? We update segments with register or memory. Parameters are wrong, right? Why? Because the instructions say that move operation can only work with segment register and memory, or segment register or register. There is no immediate S register immediate in here. Okay, so you can't directly change segment like this. You have to use a memory or register for changing segments. Segment is changed. Now I need to update AX as a 300 and put 300 in exa segment. So we update data segment as 100, exa segment as 300. Now I'm going to use those data segment and exa segment values in here. Okay. So is this correct? Let's run this code. Oops. This is just an example. Okay, we updated data segment. Data segment is already 100. We are just make sure that it's hundreds. We update exa segment. Exa segment now is 300. We are copying from data segment to exa segment. Okay. Now CX is 100H. we are in the loop. We gather value from 1000H into AX, which is 0. As you can see, 1000H doesn't have contain any value, so it gets the 0 from 1000H into AX. Now increase AX by 1, AX is now 1. Now I'm going to write this value into hexasegment back. And I'm going to go over and look at the hexasegment part. 4000, the physical address of 4000 becomes 1. These operations should work word by word because we copy starting from 1000 address, and knowing that AX is 16-bit, it copies a word starting from 1000. A word is stored in AX, word is increased by 1, and word is written into hexasegment starting from 1000 address. 1010, 1001. So actually it writes these two variables. In order to understand this more clear, I'm going to put value 1000 and 1001 H address. We put 0 ABCD H. Okay, I put ABCD into 1000H. Okay, ABCD. When you use like this, the right parameter is 16-bit, so it use 1000 and 1001. It's important. So it gather that value into AX, ABCD, increment it by 1, ABCE, move it into, write it back to hexasegment part, which is 4000 and 4001, ABCD, CE. Okay, this is correct, but when I run this code, it runs until CX becomes 0. Let's assume CX is become 0. Let's go over and look at the destination part. Destination should be increased, but destination is all 0. Why? Because we didn't update the 1000H address. We keep using the same address again and again. That's why we are going to use the twins. Remember, data segment source index, hexasegment destination index. I'm going to use those registers, source index as 1000H, destination index as 1000H, and I'm going to use source index and destination index. Emulate this, run this sometime, stop at some point, go over and look at the segment. It's still 0. Why? It's still 0. I'm using twins. This address is 1000, but it's still 0. Any idea? Anyone catch the thing in here? Exactly. We didn't increment these twins. Indices. So after this operation, after both of these operations, we have to add or increase. It doesn't matter. For example, I'm going to add 2 into source index and increment destination index twice. Why 2? Why I am incrementing source index by 2 and destination index? Not 1. Why not 1? Any idea? Exactly, Ahmet. We are working on word by word. So when we emulate it here, we are copying the word 2000 and 2001. The next operation should work with 2002. The source index is 2000, incremented into 2002, 2004, 2006. Every word, starting address of word, should be operated. So this is the end of code. Let's run this code some time, stop it at some point. At first, I'm going to look at the source. Source is 0, 0, 0, 0, 0. And I'm going to go over and look at the destination. Destination is 1, 1, 1, 1, 1. Why? Because we increase every word by 1. Okay? Any question? We can also add destination index by 2. This is same, but there is no plus plus or something. Be careful, there is no plus plus. Any question? By the way, it's convenient to use these twins with data segment source index, exa segment destination index, but a single index is also enough because they are both showing the same address. Let's get rid of this destination index and use source indexing and get rid of this code. We are using single index operation in here. This will result in same code. Exactly the same result. But it's more convenient to use data segment source index, exa segment destination index. Like gathering value from source and writing it to destination. Okay. These first lines, we are using data segment and exa segment. Remember, when we emulate and write 300 in here, we are not stating that we are using exa segment or data segment. We are just writing something and go look at the value directly. So you don't have to use exa segment and data segment. You can use a single segment, let's call data segment. I'm going to delete all above and only going to use data segment. We are just trying to manipulate our code. It's more complicated. If you don't understand till now, just don't worry. I'm going to use data segment in both of these parts. Let's write this in here. AX, we keep using AX. Let's use BX. 100H into move data segment BX. Data segment is now 100. Move this value out of here and move other variable 300H into here. And before that, I'm going to update data segment again with DX, which is 300H. BX is 100H. This is also correct. Data segment is default 100, exa segment is default 100. I'm not going to use exa segment. It's only working with data segment. This can also be true. BX, CX 100 value, update data segment to 100, it's already 100. Gather value from AX, put it into update data segment 300, put it into 300, increment, turn it back to here. Let's go over and look at the 300. Oops, it didn't work. Why not? It didn't work. Because we get rid of the source index unintentionally. You still need the source index. Okay. 2 times these loops run. Let's go and look at the 300. As you can see, 4000 and 4002 address already updated. I didn't use hexasegment, but I only use data segment. If you don't explicitly show segment before these addresses, it gathers the data segment. This is again the same code. It will use data segment as a segment in here. It's still correct. But the more appropriate way was using data segment, hexasegment, source index, destination index separately, so that the code will be less like this. Get rid of this line. Source index, hexasegment, destination index. This will be the more appropriate one. Okay? Any question? Any question about anything? Loops are working with CX. It runs CX times until CX becomes 0. Okay? Is there any question to Muharrem, Mr. Muharrem? Muharrem hocam.
Arkadaşlar sorusu olan arkadaşımız var mı?
Yoksa kaydı bitirelim hocam.
Tamam, teşekkür ederim katılımınız için arkadaşlar. Kaydı durduruyorum. İyi akşamlar, hoşça kalın.
İyi akşamlar hocam.
Teşekkür ederim Abbas hocam. Sağ olun.
İyi akşamlar hocam.